Hi calculus friends. So after our discussion about interval and radius of convergence of sort of generic power series having to do with that web work question that we did in class on Wednesday, I felt like there was still a lot of confusion, and so I decided to make this little video. Hopefully this will help. Let me know if you have any questions. So let's say that we are looking at some generic power series, like, I don't know, this one's, I don't know what the coefficients are, I'm being super generic about this, but I have x minus 2 to the n. Well, so just by looking at this generic power series, we can tell that the center is at x equals 2. The center of the interval of convergence, that is. And we can tell that because of this x minus 2 to the n term in our power series. So let's say that we knew something more about these coefficients and we did the ratio test, right? So we were like the limit as n goes to infinity of Cn plus 1, x minus 2 to the n plus 1, divided by Cn, x minus 2 to the n, and we work out all this stuff. Oh wait, we need that in absolute value. We work out all this stuff and we end up with, say, I don't know, 1 over 3 times the absolute value of x minus 2. Now for the ratio test, to tell us that a series converges, we need that the limit of the ratio needs to be less than 1, right? So in other words, we would have that x minus 2 is less than 3. This number 3 is the radius of convergence. But what this is telling us is that the distance between x and 2 has to be less than 3 in order for the series to converge. So it's guaranteed by the ratio test that the series will diverge at x values that are more than 3 away. For example, if x equals 7, let's put that into our conclusion from the ratio test here. So then we would have 1 over 3 times the absolute value of 7 minus 2. Well, that's 5 over 3, which is certainly bigger than 1. And so the ratio test tells us that we diverge because the limit of the ratio was larger than 1 when x equals 7. Similarly, it's also guaranteed by the ratio test that the series will converge at x values that are less than 3 away. For example, if x was 4, we would have 1/3 the absolute value of 4 minus 2, which is 2/3. And since that's less than 1, the ratio test guarantees that we will converge. And in fact, we know that this is going to happen for any x value that's less than 3 away from 2. So any x value between -1 and 5 will, the ratio test will guarantee that we'll converge for that x value. So now here's the tricky thing. What happens at the endpoints? Let's just look at this in exactly the same way that we looked at these other two values. So let's take one of our endpoint values, let's say -1. And let's look at what happens when x equals -1. Then our conclusion from the ratio test is 1/3 the absolute value of -1 minus 2, which is 3 over 3. That's a 3, I promise, which equals 1. Uh-oh, the ratio test is inconclusive. So that's a bummer. The ratio test doesn't tell us anything about what happens with this series when x equals -1. I'm going to have to use some other test to figure out what happens. And since the series is so generic, there's sort of no other test that I can officially use right here. So we might converge, we might diverge, I don't really know. So then let's write down some various possibilities for the interval of convergence. The interval of convergence could be, say, -1 is less than x is less than 5, and we diverge at both of the endpoints. Or maybe it could be -1 is less than or equal to x is less than 5. Right, we could converge at this endpoint, -1, and diverge at this endpoint of 5. Or maybe it's the other way around, right? It could be -1 is less than x is less than or equal to 5. Or maybe it could even be that -1 is less than or equal to x is less than or equal to 5. We could converge at both endpoints. I just don't know. So, just for fun, now let's pretend that something different happened. And when we did the ratio test, let's say that we got 1/5 x minus 2. Again, we would need that to be less than 1, and so we would have that x minus 2 is less than 5 in this case. So now 5 is our radius of convergence. So again, we're guaranteed that the series will converge for values of x that are less than 5 away from 2. So let's see, we could go all the way up to 7, and we could go all the way down to negative 3, and we will certainly converge for x values between negative 3 and 7. However, we might also converge at negative 3 or at negative 7. So our interval of convergence could be like this, or it could be like this, or it could be like this. I just don't know. I would need to use some other test on my power series. So here's the big idea. The ratio test, because it's inconclusive when the limit of the ratio is 1, it doesn't tell us what happens at the endpoints of the interval of convergence. We have to use some other test. The series could either converge or diverge at the endpoints of the interval of convergence. So with that in mind, let's now look at this webwork problem. I pulled this up with some different numbers from the ones that we were looking at in class. So now what we have, we can tell by looking at the power series that the center is negative 3. And we know that we converge at x equals 2, and we know that we diverge at x equals negative 10. Why don't we look at this on a number line? I think that will help us figure out what's going on. So here we are at negative 3, and when x equals 2, we know we converge. And when x equals negative 10, we know we diverge. So here's some things that we definitely know about the radius of convergence. The radius of convergence certainly can't be smaller than 5, because the series converges at a value that's 5 away from the center. So the ROC is at least 5. And in fact, it can equal 5 because that would put 2 at the endpoint of the interval of convergence, and a power series can converge at the endpoint of its interval of convergence. Another thing that we know is that the radius of convergence can't be bigger than 7 because we know that the series diverges at a point that's 7 away from the center. So the radius of convergence is at most 7. Now it could also equal 7 because that would put negative 10 at the endpoint of the interval of convergence. And so again, a power series can either converge or diverge at the endpoints of the radius of convergence. Let me illustrate my point here by exploring what the interval of convergence could be if the radius of convergence was 7. So again, we know that any x value that's less than 7 away from negative 3, the series will converge at. So anything between negative 10 and, let's see, 4, I guess. But then we don't know what happens at the endpoints. So the interval of convergence could be, say, negative 10 is less than x is less than or equal to 4. And that would actually match the facts of the problem here. We would converge at 2, and we would diverge at negative 10. Or it could be like this, and that would again match the facts of the problem. The facts of the problem make it not possible that this could happen, or this, but those are otherwise reasonable things for the interval of convergence to be. So that means that we know that the radius of convergence is at least 5, it's at most 7, and it can be either 5 or 7. So that means that the radius of convergence has to be in the interval 5, 7, and hard brackets on each because it can be either of those. So I hope that this video helps. It's not the prettiest video in the world. Deal with it. If you have any questions about this, let me know. I'm sure we can talk about this some more.